The objective of this lesson is to recognize the relationship between degrees and fractions of a whole and relate this understanding to the design and use of a circle protractor. In the previous lesson, students learned how to name angles with specified rotations in relation to fractions of a circle. In this lesson, they will relate that knowledge with use of a circle protractor. Let's take a look at this circle and begin by dividing it into fourths as if we were cutting a pizza or pie. What is the fraction each piece represents? 1 piece out of 4, or 1/4. If we partition each of the fourths, what is the new fraction for this piece? 1/8. If we take this piece and partition it again, what is the new fraction that names this piece? 1/16. Could this pattern be continued? Just as a space on a number line can be subdivided, so can the fractional pieces of a circle. There are standard units to measure attributes of length, such as inches, or weight, using pounds, but since angles cannot be measured with a ruler or a scale, a standard unit is also used to measure angles. To create this standard measure, a circle is partitioned into 360 wedges. This creates a fractional piece that is small enough to accurately measure angles. Here is 1/360th of a circle, and it is also called a 1-degree angle. Degree is abbreviated with a small circle drawn at the top right of a measure, just as it is done with temperature. What size angle would be produced if a 1-degree angle was iterated 3 times? That would be 1/360th plus 1/360th plus 1/360th, or 1 degree plus 1 degree plus 1 degree, which equals a 3-degree angle. What if a 1-degree angle was iterated 10 times? That would be a 10-degree angle. It becomes difficult to iterate 1-degree angles when measuring large angles. The tool used for measuring angles is a circular protractor. How many sections is this protractor divided into? It looks like 360 degrees. Do you see there are 2 sets of numbers? Most protractors will have 2 different number lines labeling degrees. One increases clockwise and the other increases counterclockwise. When measuring degrees, it is important to remember that measuring angles is measuring the rotation a ray would need to make from one position to the next. First, we start by finding 0 on our protractor. Place the vertex of the angle in the center of the circle protractor and align one ray so that it points to 0, and follow the protractor until you see where the other ray points. If the angle is exactly 1/4 of a rotation of the circle, one ray points towards 0 and the other points towards 90 and 270. We know that a circle is divided into 360 pieces, so does this angle represent 90 degrees or 270 degrees? If the ray rotated at 1 degree at a time, would it be closer to 90 degrees or 270 degrees? Probably a rotation of 90 degrees. This is a special type of angle known as a right angle or square angle. To mark this special kind of angle, a square is drawn into the angle rather than an arc. But what if we rotate the segment to show an angle that is 3/4 of a rotation? Is this angle larger or smaller than the last one we made? Definitely larger. This angle's measure must be 270 degrees. Your child will continue to measure angles of different sizes using a circle protractor. They will learn that the arc between the 2 rays indicates the angle to be measured. By thinking of degrees being the rotation around the circle, there will be less confusion about which degree measure should be used. The objective for this lesson was to have students recognize the relationship between degrees and fractions of a whole. We met this objective by having students use their understanding of fractions of a whole and measuring degrees with the use of a circle protractor.